This is a follow-up video for the joint and disjoint variables within probability. We're going to be going over two examples, multiple questions concerning the examples. So let's get to it. Here are our two examples. Taken from the last, the first one's taken from the last video. Computer store, 85 hard drives, 65% brand A, 24% brand B. Here, the last example was the Sprite and Fanta. I'm going to make things a little bit more interesting this time. We have 400 students in the school. Percentage, 85% take math, 10% in stats class, 40% in art class, 30% in both math and art, and we have 8 students that are in stats and art. So given a bunch of information. Let's start off by drawing the Venn diagrams. We didn't do a Venn diagram, I don't believe, for the disjoint example. We should actually talk about variable first, I suppose. Let's do a little checklist. This can be very helpful because this video is actually pulling together an awful lot of what we've been doing previously. So what do we have? Is this a discrete or continuous variable? Well, it's discrete. Is it dependent or independent? This is actually a very important question. So the way to really think about this is we have our 85 hard drives. If we were to select one hard drive and then a second hard drive, would the probabilities associated with that second draw depend on what happened in the first draw? So if we, in the first draw, got a brand B hard drive, there are now fewer brand B hard drives. The total number of hard drives goes from 85 to 84 because we've selected one out. So the probabilities are going to shift. So this is in fact dependent. And then is this joint or disjoint? In a single draw, this is how to think about joint versus disjoint, can it be both A and B? Well, no, it has to be either brand A or brand B. Can't have both, so that's disjoint. Let's do a little checklist here. So discrete or continuous, right? Can we have parts of students? No, not really. So this is discrete. Now, dependent or independent. Again, if we randomly select one student, then another student, will the probability that the second student change depending on what happens with the first? The answer is yes. We have a finite number of students, 400. So you remove one, it's going to change those numbers around a little bit. So this will be dependent. Dependent. I'm not sure how to fix that. There, dependent. Now, joint or disjoint? We already know, actually, can you take both math and art? Yes, we're actually given that information. So this is the joint example. All right, so now that we've identified what kind of questions they are, what kind of variables they are, let's draw the Venn diagram. Let's do this one first. All right, we have, this represents our 85 hard drives. We can have brand A, which is 65%. And over here we can have brand B, which is 24%. And I've kept them separate because it's disjoint. You can't have both. There is no intersection between them. Now, if you add up 65 and 24, that would be 89. That's not 100%. So there must be a number of hard drives that are neither. So we could figure out, right, probability of neither. Well, that would be, oops, let me undo that. Our 100% minus our 65% minus our 24%. So the probability of neither is 11%. Right? So neither is 11%. All right. Let's look over here at our school and see if we can make a decent Venn diagram of our 400 students. So we have a big circle, which is math, which is 85%. Now, the interesting thing here is this stats, 10% in stats. Well, stats is a math class. So all of the stats circle is within the math circle. Right? So here we have stats, which is 10%. So what percentage of math students aren't taking stats? Well, you subtract to be 75%. Now, we have this 40% take art class, and there's a lot of overlap. A lot of the art students also take math. And we know that some of the art students that take math are also in stats. So maybe we could draw something like this. That looks pretty good. Right? We know that 40% take art. 30%, let's get some colors going on here. Let's see if this will work. Right, here's that intersection between math and art. So really, that's going to be our 30%. And these 8 students that take stats and art, well, that's just going to be right in here. Right? 8 students. Not 8%, 8 students. All right, so now those look pretty good. What I find to be convenient, because these are both dependent variables, and so the probabilities will actually change with multiple events. I like to just make a table of some initial numbers, which would look something like this. We have our brand A, brand B, and neither. 65% of our 85 hard drives, 24% of the 85 hard drives, and 11% of our 85 hard drives gives us these. But there's a problem, because of course these are discrete variables. Can we have 55.25 hard drives? No, at least I would never buy the 0.25 hard drive. So really, what this should look like is 55, 20, and 9 using just standard rounding convention. But let's just do a little check here. If we add these together, we get 84, not 85 the way we're supposed to. Well, that's a round-off error, which with discrete variables, because you have to round them, can sometimes happen. The way I usually deal with this is I look at the decimals and say, well, what's the closest one? I need one more hard drive somewhere. Well, what's the closest one that could have rounded up? It seems like the 0.4 is the biggest one. So I would end up using 21 brand Bs, and then that would give us our 85 hard drives. For the school over here, we're going to have more categories. Here we only had 3 categories, brand A, brand B, and neither. We're going to have more categories over here. So I need some space. I'm going to shrink this down a little bit. There. I hope you can still read that adequately. And now let's look at what categories we could list off. Here are the first two that come to mind. Right? There's the only math, which would be just in this. Here, maybe I'll highlight to show you. The only math would be this area. Right? That's the only math. I'm going to actually erase this because there's just going to be too many colors kicking around. But that's what I mean by only math. And of course, we can talk about only art, which would be that area. Right? That's only art. There's a lot of categories you could think of when we have a complicated Venn diagram like this. There's a lot. So I'm not going to list everything. I could list, math and art, which would be the 85% and the 40%. If I need those, I can get those maybe later. I'm just going to get a few of the salient parts and some of the detail parts, which we can use to get other things that we need. So, for example, we might like this piece, this stats and the art. And the way I'm going to actually write that looks kind of like this. Remember, this symbol means intersection. All right, so this is the intersection of stats and art, right, which is going to be right there, the red. I like using this instead of, some people just say stats and art. We've talked about and or, and we have multiplication rules and things like that, which don't entirely apply to this. This isn't what we're really talking about when we do an and, when we say the word and. So intersection, I think, is a little bit more clear. It makes it so that people don't start throwing in the multiplication rule in strange places. And here are a couple others. We can have the non-stats math, which would be intersecting with art, which would be this area in here. Right? That's your non-stats math and art. And then, oops, that didn't erase. There we go. And then only stats. I put that in because we have these sort of 8 students. We can really think about, or we might need, the only stats section, which would be, of course, this. Right? It's only stats. They don't take any art, and they're in math. They're in stats class. So this is only stats. So now let's try and get the numbers for these just like we got the numbers of hard drives. Here are the beginnings, right? And what I'm doing is doing an initial probability, right? Because we don't actually have the only math probability. Over here, you do probability times the number to get your actual number of students, in this case, hard drives over there. So we had to, subtract this intersection part. So I got the 55, and here 10% for only art. Now for the stats and art, this is kind of interesting. This is where we have 8 students. We're not given probability at all, so we actually have to calculate the probability. So that's 8 students out of how many? Well, 400. And this turns out to be 2%. And if we're looking for the intersection non-stats, math, and art, which would be, again, this sort of outside shape here, well, we can take the 30%, which is the intersection of math and art, and subtract away this little stats part, which is what I did here. So that would be 0.28 or 28%. And then, only stats, right, which is this upper part here, now the stat students that are not taking art, of course we'd subtract away the little 2% here from the 10% that are the stat students. Now we get 8% of the school is taking stats without any art class. And now I can calculate my numbers of students in each category. Again, probability times the total number of students. And we can see how many students are in each category. All right, so that's just some nice information that we will need to start answering questions. We haven't really even gotten to the questions yet. Let's start those now. Here's a good starting question. What's the probability that a randomly selected hard drive will be brand B? Now, before we get into the answer, which is fairly straightforward, I want to draw some attention as to the kind of question this is. This is a single event. We're drawing one hard drive. So there's one random event happening, that one draw. It's a little bit more than just single event. Not only is it single event, it's the first event. This is going to become important because these are dependent variables. And so if we start talking about subsequent events, like the third draw, the fourth draw, after a number have already been drawn, that changes the numbers, and we have to deal with that. So, but this is a single event and is the first event, which makes it fairly straightforward. What's the probability of getting brand B? Well, if we look at our Venn diagram, brand B, 24%. So probability of getting brand B, 24%. Over here with our school example, what's the probability that a randomly selected student will be in a math class that is not stats? Again, it's a single event. We're selecting one student. It's the first event, which is important because this is dependent variable. So we look back here. We're looking for math without stats. And if we look at the question, is in a math class that is not stats. We have to consider the whole art issue, which is an important consideration, considering I didn't write the entire question up. Oops. I need to actually look at all my notes. Here's the rest of the question. So now it reads as it should. Randomly selected student will be in the math class that is not stats and also in art. So if we were to write this out with in probability notation, it would look something like this. Non-stats math intersecting with art, right? We want both of them. Well, if we look back here, we have our non-stats math intersecting with art. It's actually one of the categories we already calculated, where I know it's 28%. We can just pick it right off of our table. Right. Single event, first event, not too bad. Let's go back over to our computers and look at a different kind of single event. It's almost the same as the first one, but we have our OR. Probability that a hard drive randomly selected will be brand B or neither. If we wrote it out in probability notation, it should look familiar, and we have an OR, so that would be the addition rule. And we can plug in the numbers, and we get our answer of 35% chance of selecting B or neither. So we'll do something similar. We have an OR now for our school question. Probability that a randomly selected student will be in a math class or an art class. So if we write this out in probability notation, it would be something like this: probability, math or art. This is a joint event. So we talked about the formula that you would need for this, which would be the probability of math plus addition rule, probability of art minus the intersection of math and art. We talked about that using the Venn diagram in the last video. So we could plug in our numbers, and we would get 95%, which if we looked at the Venn diagram for the school, right, what we just found was the union of math and art. We subtracted one of the areas of intersection, and that gets us that union. So this brings up actually an interesting question about this formula. And yes, you can apply it. It applies to joint. Could you actually use this same formula for this disjoint example? And the answer is actually yes. Here's this question with the full joint equation. Probability of B plus the probability of neither minus the intersection of B and neither. Well, let's put in the numbers. What is this number? How much do these two intersect? Well, they don't. So really, that's a 0, and that term just drops out. And you get your answer of 35%. So in fact, this bigger equation that includes the intersection term is the more general. It applies to everything. We just don't usually write it for the disjoint examples, but we could. And over here, even for joint examples, there might be situations where the question is written in such a way that there is no intersection, and this might become 0 also. For example, if we were to rewrite this question, or really make a new question, what's the probability that a randomly selected student will be in only stats or only art? Well, we would write out the probability like this. And if we wrote the whole formula out, it would look like this. And then we could refer back to our Venn diagram, back over here. And we can start looking and say, well, here's our, only stats, right? And we figured out down here that that's 8% are in only stats. And only art, actually maybe I will highlight. So here's our only stats. And then only art is down over here. And we have that's 10%. So that 10% and the 8%. Is there any intersection? No, there isn't. I'm just going to clear that out. Well, if there's no intersection, then we plug in the numbers like this. And we get 18%. There is no intersection, it drops out. And we have 18%. So we've talked about single event, first event type of questions. Let's now move on and talk about single event, subsequent event. So now it's not the first draw, but the second or third or fourth draw. And we know because we're talking about dependent variables, we have to worry about those numbers changing with each subsequent event. Here's a good question. 2 hard drives are randomly selected. What is the probability that the third hard drive that gets selected is, I think that's supposed to be an is brand A, if the first 2 turned out to have been brand B and one of the ones that were neither brand A or brand B. So this is the third event, but we're still just asking for the probability of that one event. It just isn't the first event. So what we can do is look at how the numbers change with each event. And I usually do that in kind of a table format. I find it a little bit easier. You can do it with just brand A, because that's really what the question is about. Or you could have all the categories. For this first one, maybe we'll just show all categories, although that's not entirely necessary. So before the first two draws, we have 55 hard drives that are brand A, 21 that are brand B, and 9 that are neither A or B, for a total of 85. Now, after those two draws, and it's after both of them because I'm not interested in really the probabilities of the second draw. Well, we didn't draw any brand A's, so we still have our 55. We drew brand B, so that's now down to 20. And we drew one that was neither, so from 9 it went down to 8. And since we've drawn 2, our total is now 83. Now we can figure out probabilities, which would look something like this, because we have now a total of 83. And there are all our probabilities. Now, to write this out in probability notation, the probability of A given B and neither, right, two of previous events, the probability is 66%, which for, and this is brand A, changed a little bit, not a whole lot. It was 65%, I believe, but it did change. Now we have a nice question for the school. Right, so 20 students have already been selected. Gives you the breakdown. 5 of those 20 are only in math, 4 only in art, 8 are in non-statistics math and art. That's an intersection one. And 3 are in stats as well as art. That's another intersection one. So what's the probability that the next randomly selected student, so this is now the 21st event, will be in a non-stats math class and art class? Right, so it's still asking for a single event. It happens to be the 21st event, but still a single event. We could write this out this way. All right, probability of non-stats math intersecting with art, so it's both, given, I wasn't going to write out all of that, so all of the above, when it gets really long and complicated. Now, the point of this notation is at least some brevity. What we need to do is something similar to over here. Now, like I mentioned, we really didn't have to write out all 3 categories here. Now, the question was really about brand A. So all we really needed was actually this 83, and to know that this number didn't change. You need those 2 numbers. So with the school, there's so many more categories. It's kind of, I find, wasted effort to do a table for all of them. Let's focus in on just this particular outcome. So we have our non-stats math intersecting with art. From our Venn diagram, we know that there are 112 students in that category. We have 400 total students. Now, after, what do our numbers look like? We have 104 in this category because 8 have already been selected. And since 20 have been selected total, from 400 we go down to 380. So to get probability, now we just find that ratio, which turns out to be 27. So this turns out to be 27% chance, which is a little different than the 28% chance initially. Now, let's get to multiple events or compound events. All right, computer store. What's the probability of randomly selecting brand B and another hard drive that is neither? So we could write this out. Probability brand B and neither. All right, this is and, so we're talking about multiplication rule. We can start filling in the numbers, but then we have to stop and say, well, yes, the first selection of brand B, we know that percentage is 24, but numbers can change because it's dependent. Let's figure out what this probability needs to be. And what we can do is use our tree diagram. The first event is selecting a hard drive, and there are three possibilities: brand A, brand B, or neither, with their respective probabilities. Now we could, again, do the entire tree diagram, because each of these initial outcomes generates three additional outcomes. And if we were looking for the entire probability distribution, yes, we fill it all out. We're actually looking for something a little bit more narrowly defined. B on the first and neither on the second. So in terms of path, we're coming here and we're going here, and that's really all we're trying to calculate. To get the numbers, right? Remember this, we initially had 85 hard drives. We selected already a drive B. There were, how many neither drives? There were 9. So all 9 are still there. But now, how many drives are left for this selection? 84. So you figure out 9 over 84, which turns out to be, really 11%. Still, the difference is farther out in the decimal places. So what we can do is plug in our 0.11 there, and we end up getting 0.0264 as our probability of those two events happening sequentially. An interesting question is, what happens if you drew the neither hard drive first and then the B? Would that make a difference? And the short answer is no, not really. And again, if you were to go farther out with your decimal places, these numbers actually become the same. So it actually doesn't make a difference what order they come in. So back to the school. What's the probability of randomly selecting two students, both in stats, but only one of them also in art? So in essence, we're asking what's the probability of stats with no art and stats with art. We can do something similar. The whole tree diagram with this school example, there are, again, lots of categories, makes tree diagrams really big. So I'm going to kind of fall back on something we did earlier and just talk about the probabilities. We know our first event, stats with no art, we know that from our Venn diagram, is 8%. So our second event is going to be the probability of stats with art, given that the first student has already been selected, stats with no art. So the numbers, we had 400 students. One has already been selected, so we have 399 left. Right? We had, and if we look for the number of students in stats with art, that's 8, which, if we do that out, is 0.02005. I'm going out enough decimal places to show you that it has changed a little bit. 8 over 399 really isn't much different than 8 over 400. But it's a little different. It does change somewhat. So now we can find out the answer. And the probability is less than 1%. In that whole school of 400, I guess that would make some sense. And so that is multiple events. I will say with disjoint, we will get questions about what's the whole probability distribution, and so you have to do the tree and you get all of them. With joint events, I'm never really going to ask you a question for the entire distribution because it just gets too complicated. The one exception might be, like with the sprite and Fanta example, very simple. There aren't too many possibilities. Then you could actually get a probability distribution. But I think this video really sums things up very nicely between dependent and joint and disjoint. There's a lot of details, and I hope this has